All right, you guys. So previously we looked at what a relation is, okay? And we've looked at what a function is. Now we're going to see, can you tell if I give you a relation, whether or not that relation represents a function, okay? So we have this relation here. Remember, a relation is just a set of ordered pairs, okay? So we've got 6, 1, 4, negative 7, 10, 2, 6, negative 3, okay? Now remember, if I ask you to describe the domain are your x values. You list them from smallest to greatest. Repeated values you only list once. And same thing for the range. They're your y values. Okay, so we have that here. Now they ask us the question, does the relation define a function? Well, you have to remember what the definition of a function is. Remember, a function says that each x has its own y. Okay, so if we're looking at this, okay, we have 6 is paired with 1. We have 4 is paired with negative 4, 10 is paired with 2, and 6 is paired with negative 3. In this case, this relation does not represent a function, okay, because 6 is paired with 2 values, okay? So every x has to have its own y, but 6 is paired with 1, and 6 is paired with negative 3. So it is not a function, okay? So one way that I remember this, okay, is that if you were in the X position, you cannot cheat, okay? So I like to think about relations like relationships, okay? So relationship goals would be that people stay faithful, right? So if your X, all right, is paired up with 2 people, that is not a function. Your relationship is not functional. The goal is for everyone to be faithful. So X's cannot cheat, okay? So let's look at a couple more examples so you guys get the hang of that. All right. So in this one, we have another relation, and they want to know, does this relation represent a function? Okay. Well, as I'm looking at these coordinates, I have this x, negative 7, is paired with 49, negative 6 is paired with 36, and negative 5 is paired with 25. Well, yes, this would be a function because every x is only paired up with one y. Nobody cheated, okay? All right, let's take a look at another example. All right, this time we have negative 4 and negative 9, 0 and 4, 1 and 4, 2 and 5, okay? So what do you think? Is this a function? If you said yes, you're correct, okay? This is a function. Now I know what I said, the x's can't cheat, but in this case, all of the x's are faithful. Negative 4 is with negative 9, 0 is with 4, 1 is with 4, 2 is with 5. The cheater here, or the value that's paired up twice, is the 4, but the 4 is in the y position. As long as you are in the y position, you can cheat all day long. But if you were in the x position, you have to be faithful. So in this example, this does represent a function. So be careful. All right, let's take a look at another one. Okay, this time we have 0, 4, 1, 6, 3, 8, and 3, 10. Does this represent a function? If you said no, you are correct. It is not a function. And the reason why it's not is because 3 cheated. 3 is in the x position, and it is paired with the y value 8 and also with the y value 10. So it is not a function. Okay? I hope you guys got the hang of this.